Hey everyone, we're going to be doing a slightly simpler problem right now. I think I just posted a problem about 8 minutes ago, and it was just a little bit more complicated than I think I wanted it to be. So we're going to take a step back, and we're going to do a little bit of a simpler one real quick. This is inspired by a video I watched on that Pivot Interactive's website. Maybe I'll post it for you sometime so you can take a look at it, but it's pretty simple. So this guy over here on the left, he bounces a ball, and the ball bounces and lands, and in that distance, it actually ends up bouncing for 3 meters. And the amount of time it takes for it to make that bounce is 0.95 seconds. Uh, so I actually have 4 questions for you. So yeah, let's figure out what the 4 questions are. Question number 1. Find the horizontal part of the velocity. Question number 2. Find the vertical part of the velocity. Question number 3. Find the total velocity. And question number 4, find the angle that it launches. Now, I will say this would not, I will not ask you to do this as part of an evidence assignment, this finding theta thing. It's pretty optional. It just takes trig that we haven't focused on yet. But that said, I'm pretty sure about half of you have learned how to do that in another class. So if you know how to do that, that's great. If not, don't worry about it too much. All right, so we'll do this in 3 steps. I've hopefully set up the problem. Um, I'll give you a second to see if you can set it up for yourself. And then so pause it, set it up for yourself, and then unpause it when you're set up. Okay, assuming that you've paused it and tried to set everything up, let's go ahead and you can check it against what I have. So we have a horizontal part that we care about, and we have vertical part. The only thing they do share is time. Now this time we actually know what time is. Time is 0.95 seconds. What we don't know in either case is the initial velocity. In fact, that's what we're looking for in both of these situations. We do know that the ball started off on what we're going to call spot 0 and ended up on the spot we're calling 3. We know that there is no acceleration left or right. Vertically, we know that the ball starts off at spot 0 and ends at spot 0. So that makes things pretty easy. The acceleration is negative 10 meters per second squared. And again, we're looking for that initial velocity. So hopefully, given that information, we should be able to find all the other things that we're looking for. Go ahead, take a moment, pause it, see if you can figure out how to do it. All right, I'm going to walk through the rest of this. Hopefully you've had a chance to already actually go through and do the math. I'm going to just do it algebraically. Maybe we'll try a graphical one later, but I think this will work for now. So let's go ahead here. Let's do the horizontal stuff first. So the equation that usually matches my horizontal part of the model is x equals v times t plus x naught. So I'm just going to go ahead and plug in everything I can. We know that x is 3.0 meters. We do not know v. We do know that t is 0.95 seconds. And we know that the x is, the original x was 0 meters. So we end up getting that the velocity must be 3.0 meters over 0.95 seconds. Throw that in my calculator that you can't see. I get 3.16 meters per second. Seems pretty reasonable. I think that would make sense for someone bouncing a ball going about, what's that, like 10 miles an hour? I think that's pretty reasonable. Now vertical, we have to use a more complicated equation because remember, we have acceleration now. We didn't have acceleration here on the horizontal part. So as far as the acceleration goes, we have to use our the quadratic version of the equation. Y equals 1/2 at squared plus v naught t plus y naught. Let's Let's just go ahead and plug things in. I know that 0 meters is where it lands. That'll be 1/2 times negative 10 meters per second squared times t squared. Oh, but we know t. T is 0.95. If I can write, there you go. Plus the initial velocity that we do not know, plus 0 meters. That's supposed to be a 0, my goodness. There you go. All right, so we have to solve this now for V naught as well. Now, just to be clear, this V naught over here is horizontal, whereas this one here is the vertical. So I'm just going to go ahead and start doing the math for this. What I end up getting is that V is equal to 5. If I can, let's do it this way. We'll just do it step by step. I'm going to move this V naught over here, and then I'm going to make everything positive. So V naught times 0.95 seconds is equal to, I'm also going to multiply the half by the 10, 5 meters per second squared times 0.95 seconds squared. I have 0.95 on both sides, so I'm going to take out one of those, which gets rid of the squared. So I just end up getting that V naught must be 5 times 0.95 seconds. All right, so again, running that through the calculator that you can't see, I end up getting 4.75 meters per second. And again, that seems like at a reasonable speed. So yeah, let's see what we've done. So looking back at our original goals, we found V naught. So V naught in the horizontal is right here. We found V naught in the vertical. Now we just want the total. Now to find the total, we want to add these together because there is some amount of velocity in the horizontal and there is some amount of velocity in the vertical, and we need to add them together into one total velocity. And we got to figure out what that total velocity is. But when we're adding things together where one's horizontal and one's vertical, what we have to do is use the Pythagorean theorem. So Pythagorean theorem-wise, 3.16 meters per second squared plus 4.75 meters per second squared is equal to our final velocity squared. Again, in the calculator you can't see, 3.16 to the power of 2 is 9.9856 meters squared per second squared plus 4.75 to the power of 2 is 22.5625. Let's go ahead and add them together. I get a total of 32.5481. That's a 4. That will be equal to v squared, therefore v ends up being 5.7, which again seems pretty entirely reasonable. So here our total velocity overall seems to be 5.7. All right, last but not least, I do want to find this angle. And again, this is not something that we've covered a ton in this class, but let's go ahead and lay this out. We know that our total velocity right here is equal to 5.7. Now that's in 3 parts. We have a horizontal part, which we know is 3.16 meters per second, and a vertical part, oops, and a vertical part, which is 4.75 meters per second. And what we're looking for then is theta. So you're welcome to use any of your trigonometric functions. They'll all work. I don't know. I'm going to pick cosine. Why not? So we know that cosine of theta is the adjacent over the hypotenuse. That's 3.16 meters per second and 5.7 meters per second. And if you want to get rid of cosine, well, it's not too bad. You just use the inverse cosine function. But if you do the inverse cosine function to that side, you also have to do the inverse cosine function to this other side. So sorry, my math's a little bit ugly, but that's what I'm about to type in my calculator. So 3.16 5.7 divided, and then inverse cosine gives me 56.35. If you didn't get that, make sure you're in degrees mode. But I would say this seems about a 56.35 degree angle. I think that's pretty reasonable. Watching sig figs, let's go ahead and round some of our answers. We can't do better than 56 here. This guy right here, 3.2 meters per second is probably that fun. Let's make it, let's color code things nicely, shall we? The vertical here, 4.8 meters per second, and then our overall is fine at 5.7. All right, everyone, so 4 different answers to our problem as listed and defined up there. A little bit simpler of a problem, don't get me wrong, there was a lot of work, but that was because I was asking for 4 different things. I hope you can see that every time we're doing these problems, they're all kind of done the same way. It's all just lay out what you know and see how it fits into our 2 equations. All projectile motion sort of seems to work like that. All right, everyone, do let me know if you have any questions. Stop by the Discord and have a nice day.